So let's start the recording. Yes, you can, the assignment is already there. You can have a look at it if you want, or you can wait a little bit more. But you can open it and close it and as many times as you like. And it's not, you don't have to do it in one go. So if you have any issues with it, please let me know. If there are any problems at all, any questions perhaps you don't understand, you can send them to me by email or yeah. Okay, so yes, so check the assignment if you want, or you can wait a little bit more. Okay, so today we'll take a look at the dot product, which is an important operation on vectors. Yeah, the dot product. Of course, we looked at vectors and we talked about various things, parallel vectors, unit vectors, how to add vectors, and so on and so forth. So today we will add one operation, which is called the dot product of two vectors. The dot product in 3 dimensions is defined here by this rule. So if you have a vector A that you want to multiply by a vector B, the dot product, so that's a dot, and you point there. So it's A1 multiplied by B1, so you get A1, B1, and then you take A2 and you multiply it, yeah, by B2, so you get this A2, B2, and finally A3 multiplied by B3, and you add that also, so you will get this. So in 3 dimensions, it's this. In 2 dimensions, it's here, yeah. So in the plane, it's just A1, B1 plus A2, B2. Okay, so very simple operation, but it is quite important. It will allow us to study vectors in a quite an easy way. So here are 2 vectors. A is here and B is here. So I want to find the dot product. So A dot B, like this. So what is it going to be then, girls? Can I get some help here? So it's 1 times 5, 1 multiplied by 5, yeah, plus, remember you need to add, yeah, Salha, you need to add. So plus the 2 that you multiply by the minus 3, and you add also, yeah, you add the 3 multiplied by 4. So the final answer is a number, yeah, the final answer is going to be a number. It could be positive, it could be negative, it may be even 0. We don't know. So if you do this operation now, you will see that it's going to be 11. Yes, 11 is equal to, yeah. So the dot product of these 2 vectors is equal to 11. Very easy, no problem at all there. In R2, so in the plane, of course, A, I can write A as, what is the vector A? It's maybe better to write it like this. It's 2, yeah, minus 5. And then you write B. Yeah, B will be 3, 6. And then you can, thank you, Noor, yeah. And then, so that means the dot product A dot B is going to be 2 times 3, yeah, 2 times 3 plus minus 5 multiplied by 6. And you do this, Yeah. So it's going to be 24, so 24. 24 is the dot product of these two vectors. Yep. Minus 24, yes, thank you. Yeah, minus 24. Yeah, minus 24. Okay, good. So that's basically what the dot product is. It's a simple operation. You can calculate that without too many problems. Now, when we work with dot products, there are some rules. There is a theorem here. So you do A dot B. Well, it's exactly the same as B dot A. So that is, so you have the dot product is commutative. Then if you have A dot B plus C, it's the same. You can distribute, basically. You have a property of distributivity here. So it's A dot B plus A dot C. dA dot B is the same as A dot B first, and then multiply by D, etc. A 0 multiplied by 0 dot A is 0, and then A dot A is equal to the magnitude of A squared. So these are all some rules that you can use when you work with the dot product. Right. Now, this idea of dot product is related to the angle between vectors. So you have a vector A here in blue and a vector B. Well, the angle between them is the angle theta, the small angle. Yeah, theta, always very important, between 0 and pi. So that is always your angle theta. So if I take a vector here, if I say here is A and here is B, well, the angle between them is this angle here. It's not the other one on the other side. It's not this one, yeah? Not this one. So it's always the small angle between 0 and 180 degrees. So that is the angle theta between two vectors. Now, okay, just some remarks. If A and B have the same direction, so if A and B have the same direction, that means the angle between them is equal to 0, like this. How about if they are in the opposite direction? So one of them is like this, and the other one is like this. So A is here, B is here. So in this case, what is the value of the angle theta? 180 degrees. Yeah, thank you. So basically, if they are in the opposite direction, then the angle theta is pi. Okay, so it's important. Opposite directions, theta is pi. Same direction, theta is equal to 0. You may also have situations where the angles, the vectors are like this. What is the angle in this time? In this case, 90 degrees. Yeah. So if they are perpendicular, or what we call also orthogonal, if they are orthogonal or perpendicular, then the angle between them is pi over 2 or 90 degrees. At this stage, I have to say that we will always use radians, please, girls. So whenever we want to find an angle, or in calculus in general, we use radians. So we use pi, pi over 2, pi over 4, and so on and so forth. So These are the situation. So same direction, theta is equal to 0. Yeah. So I could write that same direction. Theta is 0. Opposite direction, theta is pi. And then finally, orthogonal or perpendicular, then theta is pi over 2. So these are the kind of three situations. Yes, exactly. Now we are, the next step is actually we can write the dot product in terms of the cosine of the angle between them. So we have this formula. This one, you really need to memorize it, girls. You will need it quite a lot. So the dot product of two vectors AB is the magnitude of A. I don't know why this is happening. So it's the magnitude of A multiplied by the magnitude of B multiplied by the cosine of the angle between the two vectors. So A, B here, theta is here. Then the dot product of A and B. So A dot B is the magnitude of A multiplied by the magnitude of B multiplied by cosine theta. And this rule, we can use it in many ways. We can use it to find the angle theta, like so. Okay, so let's do that. Yeah, you can change, of course, this formula. It becomes cosine theta equal to the dot product over the magnitude of A multiplied by the magnitude of B. Yeah. So this, yeah. Cos, yeah, exactly. Then we use the cosine inverse to get the theta. So this rule or this rule, they are the same, but you can use whichever one you want to use. It's okay. So here are two vectors. Here is A, here is B. I want to find what is the angle between them. Find the angle between these two vectors. So you can see that from this rule, I need to find three things. First, I need the dot product. So here is how to find the angle. Girls, you will see this. Yeah. So we need to the dot product. We need the magnitude of A. We need the magnitude of B. And then we can find the angle theta as the cosine minus 1. So the inverse of A, B over magnitude of A times the magnitude of B. Okay, so first let's find the dot product. So it's going to be 2 times 1 plus 1, yeah, 1 times 5 plus, you already got it, minus 11, okay, fine, plus minus 3 times 6, so, okay, minus 11, good. So that's fine. So we already have that. Now I want the magnitude of A. It's going to be, I'm just going to give you the answer here. So it's 2 squared plus 1 squared plus, I think it's square root of 14 again, yeah? This magnitude comes back quite a lot. And the magnitude of B is the square root of 62. Okay, great. 25 plus 36 plus 1. So 62. After that, I can take all of this and write it's the cosine minus 1 of AB, which is minus 11 over square root of 14 multiplied by square root of 62. And that is going to give us the angle. Now, okay, minus 0.37. I want the angle, yeah? Just use directly cosine minus 1, yeah? Go to shift cosine, yeah? Shift cosine, and then you enter all of this number. Is it 112 degrees or something? Can you check it, please? Okay. Yeah. If your calculator is in radians, let me just... so let's give the answers in radians, 1.95 radians. Okay. So 1.95 radians. If your calculator is in degrees, let's say to the nearest degree, 112 degrees. So this is fine, or this is fine. It's up to you. Yeah, whatever you want to write is okay. If they ask you to give the answer in radians, you need to give this. If we want the answer in degrees, then you need 112 degrees. Are we okay with this, girls? Anyone? Anyone has a question? It's okay? All right. So remember then, you want the angle between the vectors. You want the angle between the vectors. There are three things you need to find. The dot product, the magnitude of A, magnitude of B, and then you use the formula or you use the rule that will give you the angle you are looking for. Of course, now, if we look at, yeah, if we look at this rule that is given here, yeah, the dot product A, yeah, let me just write here, the dot product A, B is the magnitude of A, magnitude of B, multiplied by the cosine of the angle between them. What happens if theta is equal to 90 degrees? Or pi over 2? What is the cosine in this case? The cosine will be 0, huh? Cosine 90 degrees is 0, so this will be 0, and therefore the dot product itself will be equal to 0. So that means we have a rule for finding if two vectors are orthogonal or not. So two vectors, A and B, are orthogonal if and only if their dot product is equal to 0. So that's the rule for knowing, yeah, if two vectors are orthogonal or perpendicular. So if their dot product is 0, yes, they are orthogonal. If their dot product is not 0, that means they are not orthogonal. Okay. The quiz. There are no quizzes, by the way, girls. Yeah, can I just go back to that question? Al-Ghalia, or yeah. Now, there are no quizzes. There are only tests. There are 3 tests. And they're usually multiple choice. Yes, multiple choice questions. So, is that your question? Yeah. No quizzes. Yeah, there are 3 tests. They're all multiple choice. And of course, the final exam, same thing, multiple choice. So that's how things are at the moment. Okay, so, all right, that's fine. Determine whether the following vectors are orthogonal. So let's see, we have two vectors here, A, which is 1, 3, minus 5, and B, 2, 3, 10. My question is, are these two vectors orthogonal? Do they make an angle of 90 degrees or not? Yeah? Are these two vectors orthogonal or not? So what do we do to answer this question? What do we need to find? So to answer this question, we need to find the dot product. Yes, we need to find the dot product of these two vectors, which is 1 times 2 plus 3 times 3 plus minus 5 times 10. And I don't think, so what is the answer to this? Minus 39. Okay, minus 39. Is it equal to 0? It's different from 0, sir. Minus 39 is different from 0. So that means what? What does that mean? What is this telling us? Are these two vectors orthogonal? The answer is no, yeah? The vectors, so this means the vectors are not orthogonal. So A and B are not orthogonal. So what does it mean when I say they are not orthogonal? What does that mean? Okay, that means their dot product is not 0, but what does it mean also? Yeah, their dot product is not equal to 0. But what does it mean that they are not orthogonal? That means the cosine is not 0. Okay, that means the angle is what? The angle is? The angle between them is not 90 degrees. Thank you, Hamza. Yes, the angle is not 90 degrees. So they are maybe something like this, yeah? The angle theta between them is not 90. That's what it means. Now, let's see the other two vectors in part B. Part B, we have A, which is 4, 2, minus 1. And the vector, the other vector is 2, 3, 14. This time, the dot product is 0, huh? Okay, thank you, Noor. Yes. So it's 4 times 2 plus 2 times 3 plus minus 1 times 14. And if you calculate this, then this is equal to 0. So what is the conclusion here? The conclusion is that the cosine is 0, so the theta is 90. So that means A and B this time. So A and B are orthogonal or perpendicular. Yeah, they are orthogonal. That's it. So this then is the way we check if two vectors make an angle of 90 degrees or not. So find their dot product. If the dot product is 0, then yes, the angle between them is 90 degrees. So these rules not really important here. Now, okay, right, okay. Here, a little bit of physics, components, and projections. I just want to show you here. So you have two vectors, A and B. Yeah. A could be a force. Yeah, it could be a certain force. You're pulling something in the direction of B with the force A here. Now, if you take the projection of the vector A on the vector B, yeah, then what you will get here, this side, if you use a little bit of trigonometry, the cosine of theta, yeah, will be this side, if I call it x, for example. So it's going to be x over the magnitude of A. Yeah. So adjacent side over the hypotenuse. Yeah. A over h, exactly. So from here, I can get the x. So that means the x, if you cross multiply. So what you get is the x is actually equal to the magnitude of A multiplied by cosine theta. Now, this is what is called the component of A along the vector B. Now let me continue a little bit here. So I said that component x was magnitude of A multiplied by cosine theta. But remember, cosine theta from, let me go back to the rule. Okay, let me just, yeah, I can replace cosine theta with this thing here, A dot B over the magnitude of A multiplied by the magnitude of B. So that cosine theta, I can change it a little bit. So let me do that here. So cosine theta, magnitude of A, this is multiplication, B over magnitude of A multiplied by the magnitude of B. Then you can see that this and this will cancel. And what you are getting is the component is A dot B divided by the magnitude of B. So we are getting this rule here, which is written in this rectangle here. Okay. So this is how you find the component of a vector A in the direction or along the vector B like this. So dot product AB divided by the magnitude of B, like that. Okay, it's a number. This component is a number. And then the projection, there's also what we call the projection of A over B. This time it's a vector that you find by using this rule. It's basically the vector itself, like that. So, yeah, so let's have a look at how it works. An example here. So we have a vector A, a vector B, and I want to find the component of A along B, which is a number, and the projection of A along B, which is a vector. Okay, so let me just write the rule. The projection of A along B, yeah. Sorry, let me just, so the projection, first the component, yeah. First I want to do the component and then I will do the projection. Okay. So component of A along the vector B. Yeah. This is this rule here. AB over the magnitude of B. Okay. So A, B over the magnitude of B. Okay, no problem. We can do that very quickly. So A multiplied by B, yeah, the dot product AB will be 2 times minus 1 plus what? Have I lost you there? So A is here, B is here. So I want their dot product. So plus 3 times 5 over the magnitude of B, which is the square root of minus 1 squared plus 5 squared, like this. So the numerator will be what? 15? 13, yes? The numerator will give us 13. The denominator will be the square root of 26, yeah? Square root of 26, something like this. Are we okay with that? Yeah. So that's the component. Just use the rule, basically. A, component of A along B is, this is the formula. And then the second one is the projection now. I want the projection of A onto B, or in the direction of B. Yes. Okay, if you want the component of B along A, yes, you can do that. You can also find it. But then it will be A. Yeah, exactly. But the magnitude, very good. Yes, thank you, Noor. Yes, exactly. So you just change A and B, you change them around. So you will have A dot B divided by the magnitude of A. Yes, you can do that. Yes. Yes, you can actually. This one, you can, there are other ways of writing it. The calculator will give you different, yes, different ways perhaps. Yeah. Okay. Yeah, it's okay. I'm writing it in this form, but you can write it in other forms. The calculator will not give you square root of 26 down. Yeah. All right. Now the projection. Let's have a look at the rule for the projection. It's given here. A dot B over the magnitude of B squared multiplied by the vector B. So A B over the magnitude of B squared multiplied by the vector B, like this. So please, you need to memorize these rules. We will use them. So you may be asked questions like this. I think there was a question like this in the final exam. We'll give you two vectors and we want to find the component or we want to find the projection. Component, remember, is a number. It's always a number. It could be positive, it could be negative, it could even be 0. And the projection is a vector. So A dot B, we already found that. I think that's 13, so it's 13 over, yeah, over the magnitude of B squared, which is basically 26, yeah. and then multiply this by the vector b, which is -1, 5, like this. So it's actually half. This 13 divided by 26 is half, multiplied by -1, 5, and finally I can change this, and it becomes, -1 over 2, -1 over 2, and 5 over 2, and that is the final answer. Are we okay with this? Yeah. Basically, let me just very quickly tell you what we did here. What we did was you have a vector b in certain direction. Then you have a vector a like that. Then we look at the projection of a on the vector b. Then this distance is this component. It's the size of this. And the vector itself, the vector is what we call the projection of A onto B. So this is the vector. This is the vector that you see here. This vector is the projection of A onto B, and the magnitude of this vector is actually the component. Yeah, like that. Okay, now, yes. And I think, okay, right. Yeah. One last thing here is the work done by a force. If you are, you have a certain force F, yeah, which is moving something in a certain direction D, like that. Then the work done by this force is just the dot product of F with D, like that. Okay, so you can, I don't know whether we have an example or not. We don't have an example. Let me give you an example here. Okay, so just suppose we have a force F, which is a vector. Let's say the vector 2, 3, like that. And it's 3.6. Let me check. Where is it? Is it here? I cannot see 2 points. Let me check. Oh, okay. Yes, okay, yeah, it's here. Yes, okay, yes. A force of 40 pounds. Yeah. So that means if I call this force F, that means the magnitude of F is 40. Okay, and the angle theta is pi over 4. Theta is pi over 4. And then the direction of the motion, yeah. So we are moving in this direction D. And the magnitude of D, because we're moved 5,280 feet, so we can write that as 5,280. So we want to find the work now. So we want to find the work of this force. it's F dot product with D, which is, of course, if I use the rule, it's the magnitude of F multiplied by the magnitude of D multiplied by cosine of the angle between them. So we will have this. And now we just replace. We put 40 there, the magnitude of D, 5,280, and then cosine pi over 4. And we just do the calculations and we can get the result. Yep, okay, 149,340, etc. Okay, great. So can you check what it is, please, girls? So 149. Yeah. Make sure your calculator is in radians, of course. Yep, great. Okay. 149,340. 149,340, maybe 1 if we round into a whole number. Okay, so that's basically the way we do that. Okay, what I was going to do was an example like this. We have a force F like that, and we have maybe a direction D, which goes from the point, let's say 1, 2, to the point 4 minus 5, like that. Then, okay, so you're using a force F to pull something in the direction of D. The force F is 2, 3, and D is given as the vector from this point to this point. What is the work of this force F? Find the work of F. Find the work done by the force F. Okay, so a slightly different way of doing this now. Okay. What is the vector? So we have the force F. What will be the vector D? If you have a vector D which goes from this point to this point, we can find the vector D. Yeah. What will be the vector D here? Yeah, 4 minus 1, so that's 3 exactly. And then minus 5 minus 2 is minus 7. Great. Now we can say that the work done, the work this time, I will just use the dot product of the two vectors. That's it. So this will give us the work done. So it's 2, 3 dot product with the vector 3 minus 7. And this dot product is easy to calculate. So it's 2 times 3. Okay. And then plus, yeah, 3 minus 7. And you get minus 15 as the work done. Okay. Great. So that is basically what is. So two examples which show you a little bit how to work out the work once using this formula. If you have the magnitude of the force and the distance traveled by this force and the angle between the force and the direction, or if you just have F and D as vectors, then it becomes easy. The force and D are vectors. You just find their dot product, and that will be the work done by that force. Okay, so that is basically what was here. Just maybe before we take a short break, I want to have a look at some examples here. Very quickly, I think you can give me the answer to this. We have a vector A, a vector B. What will be the dot product of, yeah, 10? Okay, great. That's good. No problem at all. Yeah. I hope everyone can see that it's 10. 3, same thing. Now for 5, the first thing you need to do is perhaps write the vectors in this form. So A will be 2, yeah, 0, minus 1. B is 0, yeah, B is 0, 4, and minus 1. So 0, 4, minus 1. Thank you, Salha. Yeah, Noor. Okay, good. After that, it's fairly simple to work out the dot product. It's 1, huh? It's equal 1. Yeah, 1. Because the first 2 will give you 0, and then 0, and then 1. Okay, great. Now, angle between the vectors. Let's have a look at one of these examples. Let me do it for 7, and then I will leave you the others. So A is 3 minus 2. B is 1, 1. Yeah? Now, if you want the angle between these two vectors, you may remember how many things we need to calculate, girls? How many things? 3, exactly, yes. Thank you, yeah. So we need to find first 3 things. First, the dot product, which I can find very easily. So it's 3, it's 1. Yeah, great, good. Number 2, what is the magnitude of, thank you, Noor, yes. So we need now the magnitude of A, which is the square root of 13, yeah, square root of 13, great. And then we need the magnitude of B, which is square root of 2, yes, square root of 2. Okay. After that, then we can say theta is cosine minus 1 of 1 over square root of 13 multiplied by the square root of 2, and this will give you what you want. So just enter all of this in the calculator, and you will find your answer. If you are working in radians, 1.37 in radians. Okay, good. 1.37 radians, or yeah, in degrees. Zaina, did you find 78.69? Okay, 78.69 degrees is great. Okay, no problem. I think you're all fine with this. We can do 9 without any problems. Now, 11 to 14. I want to know whether these vectors are orthogonal or not. Determine whether the vectors are orthogonal. So I need to find the dot product. If the dot product is 0, then they are orthogonal. If not, they are not orthogonal. So A, B. I think AB is 0, huh? It's 0 here. Okay, 0. So that means what? What does it mean, Shema? You find zeros, huh? That means they are orthogonal. A and B are orthogonal. A and B are orthogonal. Yeah. Okay. Yes. We basically remember orthogonal. What does orthogonal mean? What is the angle between them? Orthogonal means the angle is 90 degrees, huh? Yes. And the rule is, be careful, the rule is that two vectors are orthogonal if their dot product is 0. This is the rule. Very important. This is what we are using. Yeah? So you can use the dot product. Now, Salha, you ask the question. Are you getting it? Do you understand? No need, no need. Why? You don't need that. So just find the dot product of A and B. If the dot product is 0, no need to use it. Why do you want to use that? The rule is if the dot product is 0, then A and B are orthogonal. It's okay. In this case, in this kind of question, you don't need to find A, B, cosine, etc. No need. Yeah. So just find the dot product. If the dot product is 0, like here, 2 times 2, and then this times this, you can see that you will get 0. Now, if we look at 13, let's just do 13, just to make sure we're okay with that. What is A here? 3, 0, 0. Huh? 3, 0, 0. Okay, good. Then B is 0, 6, and minus 2. Now, you can see that the dot product this time is 3 times 0. So let me make sure you know what we are doing. 3 times 0, and then 0 times 6, and then 0 times minus 2. You can see that this will be zeros. Huh? This will give you 0. So what is the conclusion? Yes, they are orthogonal. Huh? These vectors are orthogonal. Khalas, that's it. No need here, don't need to use cosine or magnitude or anything. Because the dot product is 0, so yes, A and B are orthogonal. That's it. That means they make an angle of 90 degrees. A and B are orthogonal. Okay, good. What else? Okay. Now, I want to find, here is a vector. I want to find another vector, so we can call this A if we want. I want to find another vector, B, which is perpendicular to the given vector, to A. So, good question this. You need to think a little bit. I want a vector B, which will be perpendicular to A. Perpendicular means from your mind, yes, from you. You give me an example of a vector B, which will be perpendicular or orthogonal, by the way, yeah, same thing, perpendicular. So please remember this. Perpendicular and orthogonal are exactly the same word, yeah. They mean the same thing, that the angles are 90. Now, if you want A and B to be perpendicular, okay, very good. Okay, Hamza, yes, very nice. It's nice, yes. So what are you looking for? You are looking for a vector B such that A dot product with B should give you what? Should give you 0, exactly. So give you 0. So the easiest way, the easiest vector is to take 0, 0, and then any number, 5, 10, whatever, then that vector B and A are actually orthogonal. -2, -4, 1, -2, -4. I think that's fine too. Yeah. No, yes, the vector B is perfectly okay. Yeah, if you take -2, -4, and 1, that's okay too, because the dot product with A will give you 4. No, no, not. It will not give you zeros, huh? Yes, it is 0. It's 0, yes. So it's -4 and then +4 and then 0. That's okay. So this is fine. This is fine. Okay. Amira, you didn't get it? All right. Now, let me just. So what we have here is a vector like this. Yeah. And you want to find a vector B which is perpendicular to A. Or orthogonal to A. Now, if you want A and B to be perpendicular, pay attention, please. If you want A and B to be perpendicular or orthogonal, then you must have A times B equal to what? You must have the dot product of A and B equal to 0. Yeah? Okay. So just put numbers. What numbers can you use? Yeah. What numbers can you use here, here, and here so that the dot product is going to be 0? For example, if I take the easiest one is to take 0 here, 0 here, and any number here. Let's say 2. Now, if you take the dot product of these two vectors, their dot product, 2 times 0, yeah, 2 times 0 plus -1 times 0 plus 0 times 2, this dot product is equal to 0. And because the dot product is 0, then that means A and B are orthogonal, like that. So that's the general idea. Now, if you're not quite sure, you can maybe review it later and see what happens. Let's see 17. Let's just see 17. It's a little bit, perhaps a bit more difficult here. So it's going to be 6, 2, and -1. Now, can we find a vector B which will be orthogonal to 6, 2, and -1? Can someone think of a vector which will be orthogonal to A? Okay, but not equal to 0. Yes, I think they say, yeah, it should not be 0, 0, 0, because otherwise it's not. Okay, great. Now, okay. B. Okay, Noor, you are giving us Salha 2 minus 6, 0. 2 minus 6, 0 is perfectly fine. Yeah, good. So 2 minus 6 and 0, and they're perfectly fine. The dot product is 0, so that's okay. Yeah, that's okay. But you can find other vectors, huh? But -6, 3, 0, Aisha, no. That's not, if you check the vector, okay, -3, I think maybe in that case, no, that's not going to work either, huh? No, even -3. Yeah, you need to look at, yes, let me give you another example. There are many examples here. You can take perhaps 1, -3, 0, that's okay, 2, yeah. If you look at the dot product of these two vectors, yeah, definitely it's going to be 0. So because it's 6 and then -6 and then 0. So the final answer will be 0. Okay, 4 -12. 4 -12 and 0 is perfectly fine. Yeah, that's okay too. No, yeah, that's fine. Yes. So you can see that when you have a vector, there are many vectors which are perpendicular to it. There are many vectors which are perpendicular in 3 dimensions. Yeah, in 3 dimensions. In the plane, there are only 2 vectors, but in the space, there are many vectors which are perpendicular to a given vector. Okay. Right. Let me, there is also a second part here. I want to do it because it may come. Yeah. So this time, what we have is, yeah. Okay. I think I can remove this. This time, I have the same vector A, which is 2, -1, 0. I want a vector B. Now, not just any vector like we did before, not just any vector I want, but a vector of the form A, 2, and -3. What is this A here? So find the number A so that these two vectors are perpendicular. So I need to have A times B equal to 0. So that means 2 times A. So I will get an equation, yes? 2A plus. Yeah, plus, very good, yes. -1 times 2 plus 0 times -3. This should give us the 0. Yes, this should give us the 0. So I need to solve this equation and just get the value of A. It's fairly simple. So this is, you already solved it, Amira, you already have the answer. Okay, yeah, it is, yes, it's 2A and then -2 equal to 0. So 2A is equal to 2, so A equal 1. So that is the answer we are looking for. Yeah, thank you. All right, great. And so in 17, also you can check the same idea. You can find the vector like that. All right, now I want questions on component and projection. By the way, girls, these questions, these exercises we are solving here are extremely important. You will see later in your tests, in your final exam, everything we do will come from here. And I will not ask you anything we don't actually do here in class. Or so it's really important. All of these questions, very important. You need to know how to do them. Okay, so here are two vectors. I want to find the component and the projection. Okay, so I want the component of the vector A in the direction of B. Now, according to the rule, yeah, you may remember what, do you remember what the rule says? Yeah, it's basically the dot product of A and B divided by the magnitude of B. Very good. Okay. So that is basically the component of A in the direction of the vector B. Okay, so can we do this fairly quickly? So the magnitude, sorry, the dot product first. What is the dot product? Tens, huh? 10, yeah. And the magnitude of B, okay, is the square root of magnitude of B is 5, yeah? 5, yes. So there is no square root actually. There's no square root. So the whole thing is equal to 2. Yes. Okay, great. So that is the component, and then which is a number, you may remember. Yeah. And then we need now to find, yeah. Let me just check. Okay. Okay, so we need to find the projection now. Yeah, the projection of A is this time, you may remember A, the dot product, A times B over the magnitude of B squared multiplied by the vector B, like this. So it's basically, yeah, if AB is 10 over the magnitude, so that's 25, yeah, 10 over 25 multiplied by the vector B, which is 3, 4, yeah, like this. And we can, yeah, we can do the multiplication. We can simplify a little bit this, divide by 5, so this is 2 over 5, so it's 6 over 5, yeah, 6 over 5, thank you, Shema, Nor, yes, yep, and 8 over 5, great, that's it, good. All right, fine. 21, 23 are exactly the same. And then last one. I want to do this one. Yep. Last one, a constant force of 30, 20. So this is a vector, the force. This like the example I gave you just a moment ago. This force moves an object from the point 0, 0. So the D, the vector D, goes from 0, 0 to the point 24, yeah, 10. So now I want to find, yeah, so I want to find the work done by this force. Yeah, so you can write the vector D as 24 minus 0. So we write it as 24, and 10 minus 0 is 10. So this is the vector D. This is the force F. so you can find the work. So the work done is F is the dot product F with the displacement or the distance. Okay, great. So you're really quick there, Shamma. Yes, thank you. All right, so F is 30, 20, then dot product with 24, 10. So it's 30 times 24 plus 20 multiplied by 10. So are you saying 920? Anyone else can confirm this? Yeah, correct, correct, yeah. Okay, 920 units, whatever the units are. Well, you know, in general, of course, the work done. What is the unit of work in general, the international unit of work? It's the joule, yeah? Joules, yes. But the force has to be in meters, in newtons, and the distance in meters. Then what you will get here is joules, but here the units are a bit odd. Yeah, Newton times meter is the joule. So you get that as. Okay, are we okay with this? Yeah? Okay. Right. So that is the dot product, and we did everything. We did all the questions that were there. I think you know everything you need to know about this. So I'm going to close this. I just take a few minutes. I want to close this and bring up the next unit. I'm trying to do as much as I can because I think next Tuesday I have a meeting in Abu Dhabi. We have a meeting at the Ministry of Education. So I may have to miss the class next Tuesday. I will confirm this with you, but I may not be here on Tuesday. Okay, so, all right, thank you, Salha, thank you. I'm just going to close this and open the next section. Take a few minutes, relax, and I will come back.